Now let us understand characteristics of square root function, which is f of x equals to square root of x. Now as you know, x should be non-negative, right? So here we can have x values which are non-negative. That means they could be greater than or equal to 0, right? Since if I have some negative value here, let's say negative 1 square root, we don't get a real number. So those will be imaginary in nature, right? So in our set of domain, which is real numbers, f of x does not exist if x is negative. So that's kind of important to understand. So this is the function which is most restricted amongst all the parent functions we are discussing. Now, how to sketch this function? For that, let's see which are the key points which should be considered. So we'll consider key points as the values of x for which we have a perfect square kind of thing, right? What I'm trying to say is we look for x values whose square root is integer value. So for example, square root of 0 is 0, right? So square root, let me write square root here, which is f of x. Square root of 1 is 1, square root of 2 is square root 2. Let's avoid it because it's kind of difficult to draw it, right? Or plot it on the graph. Let's take 4. So 4 square root is 2 and 3 square is 9. So let me go it like this. 4 is 16, for example, right? So like this, we can take some values. So these are good values to take. 1, 0, 1, 4 and 9. They are very good values to take for a square root function. So whenever you do transformations, I'll recommend that you should take values like 0, 1, 4, 9 for x. Just plot these values on the graph. So the first one is 0, 0, so that's the coordinate origin, right? 1, 1, so here we have 1 and 1, so we get this point. 4 and 2, x value of 4, y value of 2. And then we have 9 and 3, which is 9 is here and 3 is there. Joining these points, we get square root function. Right, so that is the function f of x equals to square root of x. So that's how you can draw graph for square root function. So you've seen that the key points are, you can say 0, 0, 1, 1, 4, 2, 9, 3, right? So these are the key points like this you can take. Now graph, you can see it's only in the coordinate 1, right? Now what is the domain range for this function? Domain is x belongs to all real numbers which are non-negative. So we can write domain as x belongs to real numbers where x is greater than or equal to 0. That makes it non-negative. How about range? Range is also y belongs to real numbers where y is greater than or equal to 0, right? So what we see here is the function f of x equals to square root x is always in quadrant 1, right? Symmetry. It does not have any symmetries, right? So symmetry, none. How about x and y intercepts? Well, it starts with origin. So x and y intercepts are at x equals to 0 and y equals to 0. So it is at origin, right? Or normally when you say x intercept, we prefer to write x equals to 0. And when we say y intercept, we prefer to write y equals to 0, right? So when the question is, which are the x and y intercepts, it's good to write x equals to 0, y equals to 0, and 0 equals to 0, comma 0 is also the intercept. That's fine. That's the coordinate point of origin, which happens to be x and y intercept for the function square root x. Increasing interval. Increasing means interval during which the function is increasing. As you can see, it is always increasing. You see, it's always increasing. As x increases, y also increases. So it increases in its entire domain. So we can say increasing interval is from 0 to infinity, right? Decreasing interval, none, right? It's always increasing. And behavior is what happens when x approaches positive and negative infinity. Now, since negative infinity is not in the domain, we'll only consider x approaching positive infinity. So when x approaches positive infinity, y approaches positive infinity, right? It's always increasing. Rate of change. The rate of change you can get by drawing slope, right? So if you draw the slope, you find that the slope, if you draw a tangent, So that means by drawing a tangent at different points in the curve. Now if you draw a tangent at different points in the curve, you will see as x value increases, slope decreases, right? So it is always decreasing. So rate of change for the function is always decreasing. But it's important to note that it's always positive, do you see? So it is undefined actually at 0. It's kind of a vertical slope here. It's undefined and then it is always decreasing, but it's always positive. That is also another thing is positive, right? At origin, however, it is undefined. If you want to draw a tangent at origin, it will be kind of a vertical line. Okay, so that is how the slope is for the given function square root x. Now let's identify the characteristics which makes it very peculiar. So one of the most important characteristics which I feel is that it is most restricted function since it is only in quadrant 1. So this is a very unique characteristics amongst all the parent functions. Only square root x is in just one quadrant, right? So that's very interesting. And then, origin is a part of, origin lies on the function, and then we know it is a function which is increasing, always increasing, and the rate of change is always decreasing. That's kind of very peculiar for the given function, right? Now you'll also learn that at origin, which is this point O, the slope is undefined. Okay, so those are critical things which are important to understand for this function. We'll say rate of change is always decreasing, but we don't have, let me add here, slope is undefined at origin, right? Slope undefined. That is rate of change at origin, right? So that could be another interesting thing to compare it with other functions, right? Now, so it's kind of a vertex point for the square root function, right? Now as an exercise, what you can do is you can compare this function and find similarities between square root function and linear function, for example, right? So that could be a good question to answer. So how is square root function similar to linear function? So that is my question for you. So the question here is, similarities between linear function, let's say g of x equals to x and f of x equals to square root of x, right? So that is a question for you. Think over it, go through the videos, and then you'll get your answer, I think, right? And more important, let's restrict them when for, let's say, for x greater than equal to 0, right? Now if we restrict the domain to x greater than equal to 0, find the similarities between the function g of x equals to x and f of x equals to square root x. That should be interesting. Thank you.